Many of you struggled on the Lesson 4 lab assignment, particularly on the questions involving unions, intersections, and conditional probabilities. So in this video, I'm just going to walk you through my answer key for question set number 1. This is the question set where you were given the contingency table of Penn State enrollments from fall 2015. I have this contingency table over here so that we won't need to scroll back and forth too much. So we'll start with question A, compute P of U. So this is asking for the proportion of all students that were undergraduate students. So we have, in the first column, undergraduates, we had a total of 83,436 undergraduate students out of a total 97,494 Penn State students. So the proportion of undergraduate students in this population is 0.856. Part B, now we want to compute P of W, so the proportion that are World Campus students. Now we're going to look across the World Campus row. We have a total of 12,242 World Campus students out of a total 97,494 Penn State students. So the proportion of this population that were World Campus students is 0.126. Question C, compute the complement of U. In other words, we want the proportion of this population that were not undergraduate students. There's two different ways to do this. The way that this contingency table is set up, we have a column of undergraduate students, and then grad students, medical students, law students, essentially everyone that's not an undergraduate student is combined in the second column. So we could do 14,058 divided by 97,494, or because in part A you've already computed P of U, the complement of that would just be 1 minus that number. Either way, your answer should be 0.144. Question D is where a lot of students started to trip up, and I think this is because many of you were trying to apply the wrong multiplication rule. A lot of you were trying to say that P of U and W is equal to P of U times P of W. That is not correct. You can only multiply probabilities to find the intersection if they are independent events. We have not yet checked if P of U and P of W are independent events. Later we'll find out that they are not independent events, so that formula is not appropriate to be used in this case. The easiest way, or the way that I find that students tend to make the least amount of mistakes, is to take numbers from the contingency table. So we're looking for the proportion of the population that are both undergraduate students and World Campus students. That is this cell right here. So 7,242 students were World Campus undergraduate students out of the total 97,494. So the value of this intersection is 0.074. Question E. Again, many of you are applying the incorrect formulas here. Here we want the union of U and W. So all of the students in this population that were either undergraduate students or World Campus students. Note that in math, when we say or, what we really mean is and or. So we're going to include the students that are both undergraduate and World Campus students in this number as well. The addition rule that we're going to use here is P of A plus P of B minus P of A and B, because there is some overlap between undergraduate students and World Campus students, right? Because we have 12,242 World Campus students plus 83,436 undergraduate students, and in those counts, the 7,242 were counted twice because they're included in this number and they're included in this number. That's why we need to subtract them. So the total number of students that are undergraduate students or World Campus students is 88,436. We divide that by the total population size. And the value of this union is 0.907. This is the way that I encourage you to do it. Students tend to make the least amount of mistakes when they're working with the numbers from the contingency table. They tend to make more mistakes when they're working with probabilities. Now you could also compute this as P of U plus P of W minus P of U and W. You'll get the same number. Here we're just slightly off due to rounding. But again, I strongly encourage you, if you are given a contingency table with numbers, use the numbers off of the table instead of trying to compute all the proportions. Because see, there's 4 different places here that you could make a mistake. So it tends to be much more straightforward and less errors if you're just taking numbers off of the table. Question F. If you were to randomly select one Penn State student from this population, what is the probability that the student is a University Park undergraduate student? So we're computing another intersection here. The intersection of University Park and undergraduate student. Again, University Park, undergraduate student. The easiest way to do this is to take the number from the table. So 40,742 out of the overall total gives you 0.418. G, now we're starting to work with conditional probabilities. Given that a randomly selected student is an undergraduate student, so we know that we're working with an undergraduate student, we're only going to be looking at this column. We're going to ignore the other 2 columns. So given that they're an undergraduate student, what is the probability that they were a World Campus student? Well, there are 7,242 undergraduate World Campus students out of a total of 83,436 undergraduate students. So given that they're an undergraduate student, the probability that they were a World Campus student is 0.087. Another way to look at this is that we could say that the proportion of all undergraduate students who are World Campus students is 0.087. Given that a randomly selected student is not an undergraduate student, so now we're looking at this column, the individuals that are not undergraduate students, what is the probability that they are a World Campus student? Well, there are 5,000 students at World Campus who are not undergraduates, divided by the total number of not undergraduates of 14,058. So 0.356. Another way to look at this is that 0.356 of all non-undergraduate students are World Campus students. I, using the formulas from the online notes, check if the events U and W are independent. So P of U times P of W equals 0.108. This is not equal to the value of P of U and W that we computed earlier, which was 0.074. So these are not independent events. And we could really stop there, because with those 3 formulas for checking for independence, if any one of them is false, then all 3 are false. If you would go through and you would check the other one, so here's one other formula that I use to check this. P of W given U does not equal P of W. So again, false, not independent events. You could go through all 3 of them. All 3 of them should be false. Being an undergraduate student and being a World Campus student are not independent events. And finally, question J, are U and W disjoint events? Why or why not? Quick answer to this is no, they're not disjoint events, because we have 7,242 students who are both undergraduate students and World Campus students. These events can occur at the same time, therefore they are not disjoint events.